Hello and welcome everyone to this past marathon architect. We're excited you could join us today for Scott Reagin's session, Data Positioning. This past marathon features back-to-back live webinars delivered by expert speakers from the past community. The sessions will be recorded and posted online after the event. You'll receive an email letting you know when the recordings are available. Hi there, my name's Hamish Watson. I'm a past speaker and data platform community leader, and I'm based in Christchurch, New Zealand. I have a few introductory slides before I hand over the reins to Scott. Okay. Next slide.
Where do you want to go, Hamish? Technical assistance? Sorry.
Yes, thank you. If you require technical assistance, please use the question pane located on the right side of your screen and someone will assist you. This question pane is also where you may ask any questions. Feel free to enter your questions at any time, and once we get to the question and answer portion of the session, I'll read your questions aloud to the speaker. You're able to zoom in on the presentation content by using the zoom button located on the top of the presentation window. Please note that there will be a short evaluation at the end of the session. This will pop up after the webinar ends in your web browser. Your feedback is really important to us for future events, so please take a moment to complete it. Yep. Next slide, please. Thank you to our presenting sponsors, Influx Data. This past marathon wouldn't be possible without your support. If you'd like to learn more about them and their solutions, please visit the sponsors page in the past marathon website. Yep. Next slide, please. And of course, Past Summit 2018 will take place on November 6th to 9th in Seattle, Washington. If you haven't registered yet, use the code MARATHON to save $100 off. We hope to see you at this year's Past Summit. Next slide, please. This past marathon session is presented by Scott Reagin. Scott has more than 30 years of technology experience serving in a wide variety of roles, including software designer, solution architect, and operations and general manager. He also has experience designing and implementing complete analytic solutions for organizations of many sizes and in diverse industries. And without further ado, here is Scott with data positioning. Thanks, Scott.
Thank you, Hamish. Hello, everyone. I'm Scot Reagin. I am the Managing Director of Sensible Data Integrations. We are an organization that, as the name implies, are focused on sensible, nimble, realistic data management techniques. Most of us in the organization have come from many years of data warehousing, business intelligence, analytic backgrounds. And over that time, we've come to realize that there are some techniques, some technologies in some cases, but typically techniques and methodologies that we can use in a far more effective way to allow us to get to the final deliverable that we're all looking for, which is responsiveness to the business, the data the business needs when they need it, etc. So rather than following sort of the dogmatic and traditional approaches to data management, if we're willing to explore some more creative alternatives, we can find success sooner, and we can find success more generally and more often in the environment. And that's really the topic of today's discussion. So let me take my video so you don't have to stare at my face, and we'll kick off on our discussion for the day. There we go. So data positioning. So data positioning is a term that I made up. It's not universally accepted, but I'm pushing for its acceptance out in the BI world. And essentially the concept of data positioning is, as the name implies, the whole game of business intelligence is to place or position data into a location, into a proper form, tailored to the specific user community needs. So not necessarily tailored to each individual user, but tailored to functional areas or user groups. And if we can achieve data positioning, we can put the data where it needs to be, when it needs to be there, in the form that the user wants it, that's where we'll find success. And in order for us to understand what our new concept is for data positioning, we need to understand how we've gotten here. So what is our history for data warehousing and business intelligence? And so we have to start back in the old days, right? So let's explore why we're, with all due respect to Kansas, why we're not in Kansas anymore. And it largely has to do with why everyone died in the old days. So the way the pioneers did it, and by pioneers, I mean those of us back in the 90s, way back in the 90s, that were doing what became known as business intelligence, which was really in itself an evolution of decision support and executive information systems. But when data warehousing as a concept evolved, we had essentially this diagram, and by the way, I've been using this diagram for many, many years. We had this diagram of processing of data, managing of data. We would acquire data from multiple sources into some kind of a staging manipulation area where we would cleanse and transform and clean the data, resolve the issues with the data, and land that data either into a warehouse and then into data marts, or potentially directly into data marts, initially relationally and then multidimensionally when cubes became more commonly accepted. And that data would be consumed by users through the limited number of tools that were available at the time. There was a variety of tools, but certainly not what we have today. The key principles to this stack of data manipulation layers or technologies was centralized data management, right? Our mantra was one version of the truth. So that as a user community, whether I was consuming through a spreadsheet or consuming through a traditional report or some kind of a dashboard, everyone would receive the same numbers because the data was in fact managed very tightly through this dependent set of layers. And we were successful. We certainly met those goals. That was our guiding principles, our one version of the truth notion. It worked very well. However, even in these early days, we found that there was a gap, and this gap has gotten worse over time, but there was a gap between what we were doing and our sort of covered wagon concept of, all data must flow through these dependent layers, and what the users had started to expect and started to demand. The business now was moving more quickly. So the businesses had discovered cars and were moving in directions we couldn't keep up with, right? A variety of directions, a variety of speeds. Things like self-service BI were starting to evolve as concepts. And what about big data and the Internet of Things, right? As data started to move more quickly and become more voluminous, how do we handle that given our dependent sort of architectural concepts? The one version of the truth was a challenge for the business because the business doesn't necessarily buy into the concept of one version of the truth. The business believes in a functionally specific truth. So sales and finance and distribution and HR don't necessarily see the world the same way. There are some core concepts that are in agreement, but there are areas where they're very different sort of understandings of what the truth might be. They're equally valid, but they are different. And so the challenge of the one version was always a problem. And we also had an evolving number of tools that started to appear in the marketplace, and users were beginning to pick the tools that seemed the best fit for them, and that became a challenge for us in meeting those demands. But we're pretty smart, and we're engaged, and we care. So we got smarter, and fewer of us died. And by us, I mean projects and people in some cases, right? Some people lost their jobs. These were hugely expensive efforts, not always successful. But we got smarter, and we said, look, if we believe that we have to have a persistent data store, a data warehouse of some kind, maybe we could entertain a more efficient modeling technique. Store our data, but store it in an ensemble model, something like a data vault or a focal point or an anchor point model, still SQL Server or whatever our database might be. Still a relational database, but model it differently that would make us more nimble and more capable. And we should use accelerators. So rather than having to create things like integration services packages from scratch or cloning existing packages and modifying them to fit different needs, what if we had a scripting technology like BIML, like the BI markup language, that allowed us to accelerate the creation of new ETL processes and also make modifications very quickly across maybe hundreds of packages that require the same sort of addition of auditing capabilities or something like that. So be faster, be smarter. We also entertained the notion of a data exchange, an integration hub that said, look, rather than point-to-point ETL, where systems are changing and evolving and I have multiple flavors of ETL happening, Informatica and integration services and various kinds of stored procedures and scripting techniques, .NET programs, etc. What if I was able to create an exchange where data could be exchanged across systems very efficiently and make that part of the process more nimble? If I were able to do all of those things, I could be more responsive. I could meet the business needs more quickly. And with the evolution of in-memory models, Power BI and tabular models in the Microsoft world, I can now provide capabilities to that community of users who are analysts, who are capable and willing and have the wherewithal to use tools like these to actually do discovery more quickly in my environment. So I can accelerate all of those concepts of dependent layers, right, from acquisition to staging to warehouse to mart. I can make all of that faster and more nimble using these kinds of techniques, more capable. And it was good. So we, as the surviving pioneers of warehouse, we had discovered cars. Unfortunately, the users had discovered a variety of other kinds of vehicles. The business was still ahead of us. The business was still demanding more. The gap still existed, not because we hadn't made advances, we certainly had, but because we were still rooted in this linear dependent kind of architecture where data was available in the mart, but in order for data to be in the mart, it had to pass through the data warehouse. And in order for data to make it to the warehouse, it had to pass through our ETL transformational process and staging. So the dependencies still existed. We were just more efficient in managing those dependencies. And that's when the bandits came. And everyone died again. And essentially the bandits in this case were the capabilities of the Tableaus of the world and the Qliks of the world. Very fine tools, very capable tools. But along with those kinds of tools came this concept of, well, really we no longer need this formal BI. If we could eliminate this ETL, if we could eliminate persistent storage, maybe data warehousing is an outdated concept. Maybe this notion of having a large monolithic persistent store is just too expensive and doesn't provide value. And why should we be limited to only certain tools to consume the data? We, the user community, we can just go out and use one of these tools to acquire data wherever it might reside and do our own analysis and have our own business intelligence. Well, the sort of presumed result of all of that is chaos. It is a sense of no longer having one version of the truth, and not necessarily even having a variety of versions of the truth. It's having a sort of infinite number of versions of the truth, because the reality is that 9 out of 10, something like 90% of my user community doesn't have the technical chops to actually go out and acquire their own data, create their own relationships, understand whatever cleansing or transformational business rules need to be applied, and get to a valid result. Analysts can do it. Those that do have the chops, these are very valuable tools, but most of my community doesn't really have the wherewithal to use these tools. And so we end up with the pendulum swinging entirely in the other direction, from purely managed data to purely distributed data, and really sort of chaos ensues, in the sense that I really no longer have data that I can trust. I no longer have reports and analytics that I can make proper business decisions with. And tool proliferation continued. So more and more tools were being selected by functional groups because that particular tool met their needs. In some cases, the tools started to move in a direction of being more helpful or more intelligent, recognizing that most of my users are consumer kind of users, not analysts. The tools began to take on capabilities that say, well, you really don't actually need to understand the data, because we'll understand the data for you. Simply point us at a source, and assuming you have permissions to connect to that source, we'll sort of make assumptions. We, the tool, through algorithms and intelligence built in, will be able to create some analytics for you to varying degrees of success. Again, these are fine tools doing good things, but in some cases, the capabilities actually created the illusion of quality and correctness where quality and correctness didn't actually exist. So it wasn't quite as straightforward as those users might have hoped. So how do we solve the problem? Well, the good news is that we have the tools and we have the talent. We in the data warehouse, in the business intelligence, in the information management, whatever the title might be, we understand how to solve these problems. We have the experience. We just need to use that experience differently. It's true that we still need to acquire and manage data. We should just do that more efficiently. We should do it better. And using things like BIML as a scripting language is a very, very good start. So let's use BIML in a way that makes sense, that accelerates our deliverables. But let's think about not doing point-to-point integrations. Let's look at that data exchange, and let's look at that data exchange not as a dependency, but as a component. It's available to us. We can use it where it's appropriate, but we don't require the usage of an exchange. We'll talk about that in subsequent slides. We still do need to persist data. Data warehouses are not dead. There is still high value. There's still a necessity, really, to have some kind of historical persistent data available to us in the environment. Third normal form is fine. A third normal form is the modeling technology of the early days of warehousing. Now that has evolved as some of the limitations or challenges of a third normal form in a changing environment have become more apparent. So if we can use something like an ensemble model, good for us, that's better. And let's also think of our warehouse as not a dependency in our environment, but as an optional component. So we're starting to pull those layers apart and look at them as individual components that can be incorporated where appropriate and bypassed where not necessary. We still need to transform data. We still need to cleanse data, transform data, prepare data for consumption, which is the job of our data mart, right? That's where we bundle data together into familiar dimensions and facts to be consumed. Where we can be conformed and where we have agreement and consensus, good for us. We should at least all be able to agree on a calendar, right? January 1st is January 1st for everyone. Interestingly, though, it may be a different growing period or a fiscal period, or if I'm in retail, it's a sales period. So there are variations of time, not to mention variations of products and product bundles that might be different for my finance group than for my distribution or fulfillment team. So data marts still need them. A conformed mart, one version of the truth, is great where I can have it, but targeted marts are better. So in our philosophy of data positioning, where I might previously have something like dim product, a product dimension in my mart, I now might have dim product sales and dim product finance and dim product fulfillment. Variations or targeted or tailored versions that meet the specific needs of different communities. So one version of the truth is still a good thing, where I can have it, but there are places in our data positioned environment and our componentized environment where I can have different flavors of the truth. And you'll see an operational truth, an enterprise truth, a persistent truth as we begin to think of our architecture differently. And really the thinking of the architecture differently is represented on the image in the bottom right, which is our stepping away from our linear view of the world, our linear layer dependent architecture that creates barriers for us, that says in order for us to reach success, data must pass always through these 5 layers, these 5 steps, right? Good data managed techniques. And instead start thinking laterally. Start thinking of, again, these components as these layers as components. Well, do I need this data to pass through my exchange? Is this data shared by multiple systems? If yes, then the exchange is a good solution. If no, this data is not shared by any other solution, it simply flows directly up to a mart where it's consumed, then we can bypass the warehouse, no persistent storage if we don't need it. We can go directly from source to data mart. We may or may not use the exchange. That's just a function of is it efficient? Is it the shortest path? But we can now mix and match, and we can achieve success far more quickly and achieve success in a way that is tailored to the particular solution. So without reading each and every one of these bullet items, which have put everyone to sleep so early in the day, there are some principles that guide our path to this new architecture. And those principles really live under this concept represented bottom right, which is our goal is to deliver a tailored set of solutions, still delivering data that's properly managed, but delivering data that's positioned in the location and in the form that is appropriate to the community we're serving. We want to be collaborative, so we want to leverage our data exchange for everyone where the data exchange is of high value. We want to leverage our persistent storage where that's of high value and allow all systems to participate if they choose, but we want to remove dependencies and just allow the solutions to evolve more naturally. So our principles generally are, we're going to acquire and persist data in their native form as late as possible in the solution. And this is a concept that you sometimes will hear as late binding. So data that flows through our exchange, untransformed, uncleansed, it is in its native form. Data that is persisted in the warehouse is persisted in its native form. In the warehouse, we'll have prior versions, so we'll have a type 2 concept or a changing data concept, but still in the native form as it changes. We'll transform and cleanse and apply business rules only on consumption, so only when a particular data mart or a particular application or community acquires the data. And that's because we may have different transformational rules. So finance groups data, groups product into different bundles than sales. and fulfillment sees product in a different way as well. So we'll only apply those cleansing rules when the particular community or application requires the data. The data mart, as I mentioned earlier, where we have consensus, good for us. So we have a single version of the truth in the mart, but we will be tailored where we have a variation or a variety of models, equally valid, but specific to or different according to community. We want to have consistency, patterns, templates in the way we do business. So although we do have components now, there are rules in those components. So in other words, any solution that participates in the exchange in a consistent way. So whether that be the design of stored procedures, the shape of tables, the way we interact with a JSON interface, we want to have patterns and templates and consistency in those interactions. Doesn't mean we're rigid. It means that we have a pattern, and when an exception is proposed because it meets a particular need, then that exception is looked at and evaluated and then incorporated into the pattern once it's accepted. So we are able to evolve over time, but if we're consistent, then that promotes automation. And that means that we can now use scripting languages, and we can far more quickly create new and manage existing processes if they're all recognizable and they're all of the same shape. And again, we're removing dependencies wherever possible. If we can follow these principles, then that means that we can be more nimble. Our value proposition is we're responsive to the business. We're giving the business what they need when they need it, in the shape they need it in terms of data. But we're also still managing the data. There is a coherency. There is we can feel good about ourselves that we're doing the things that we need to do as proper data stewards and managing the data through. At a very high level, the architecture begins to look more like this. Now, this is not the entirety of the environment, obviously, but it is beginning to take shape in the sense of I still have multiple sources. We're going to think of them as participating systems in this discussion. And systems are participating in our environment either as publishers or subscribers or both. So for our operational truth, we have our data exchange, an integration hub. And we're going to see more detail on this in a moment. But generally speaking, any participating system, whatever it might be, can publish to the hub. And when that system publishes to the hub, it has no knowledge of, nor should it have a knowledge of, any other system that might subscribe to its data. It simply says, this is my data, maybe not the entirety of its data, but the data that's been identified as interesting and to be shared. This is the data that I'm publishing periodically on some scheduled basis or when an action occurs. And I'm making that data available. I have no direct connections, no point-to-point integration with any other system. I'm simply publishing to the hub, and that's my publishing responsibility. Any participating system could subscribe to data from any other system that's publishing. So I now have just created this pump. It's just an engine in the middle of my environment that provides to me an operational truth. This is the native data from CRM. This is the native data from the ordering system, right? This is native data from vendor CSV files that arrive on our FTP site once a day. Any other system can consume that data. It's stored in native form, and that system can acquire the data, transform it to its needs, and now I'm exchanging data in an operational truth way, untransformed, uncleansed, just the way it was published. The data warehouse can consume data from that exchange, from other sources as well, but typically most frequently through the exchange. So it no longer has to have point-to-point integrations with all of the variety of participating systems that it's accustomed to pulling data from. The difference is, rather than just having the current version of data, that is our operational truth, the data warehouse contains prior versions, right? So that type 2 or that auditable change data path, that is my persistent truth, still in native form and available for production of pre-bundled data marts or summary tables for reporting or whatever might be my need, transformed again according to the particular needs of the community that's consuming it. I'm going to drill down just for a moment here on the two components that I think are newer in this architecture, and that is the integration hub, the data exchange, and the ensemble warehouse. So without belaboring points I made previously, the data exchange is essentially a way of saying, look, I want to avoid point-to-point integration. One of the huge challenges I have in any data management environment is the acquisition of data from multiple systems. And what tends to start off on day one as just a simple little system A communicating to system B integration starts to become layered. Modifications to that integration happen, and new systems come online, and systems are retired, and I maybe acquire a new company, and so now I have their CRM system as well as ours, and their financial system as well as ours, and my operational integration becomes very much like the Tokyo subway system represented by that diagram in the upper right. If I can eliminate the point-to-point and say, look, I don't want these systems talking to each other. I want these systems simply publishing and subscribing to an exchange. They only speak to the hub itself. Therefore, if a system is retired, it simply stops publishing and or stops subscribing, but no other system is affected. If I introduce a new system, I simply create the integration and that system starts to publish. As its data is now available, other systems may start to subscribe, but I can manage that kind of evolution in a much more convenient way, in a much more streamlined way, and a more flexible way. Same is true on the data warehouse side. Very often in environments, we see operational integrations being done by an ops team, and we see BI data warehouse integration being done by a separate BI information management team. But conceptually, they're doing exactly the same things. The warehouse is going out point to point, pulling data from various source environments in through its stage, doing its transformations, doing all of its traditional kinds of work. Well, if I can leverage the integration hub that I've already built for operational purposes, well, now the BI environment, the data warehouse or the data marts directly, become simply participating systems like any other. Now, they may only be subscribers. They're not publishing anything to the hub. They're simply acquiring data. But all of the data from the systems of interest, is, if they're participating in the exchange, then the warehouse has access to everything it needs. One connection, one point of contact, pull the data through, and then do what I need to do as the warehouse or mart according to whatever my requirements are. If we think then in terms of new systems coming online, old systems being deprecated, I can make that change in one place. I can manage that data in the exchange, and I can serve all of these communities and relieve all of that overhead and complexity that I probably have in most environments today. A bit more detail just on publishing and subscribing, just to beat that point home, I suppose. If we think of SQL Server, for instance, as our platform here, we have our central hub, which in the simplest of environments, although it could be many databases, we'll keep it simple and assume it's one database. So I have a SQL Server database in the center of my exchange with one schema per participating system. So CRM schema, CRM2 schema, although they could have more creative names than that. Whatever the participating Salesforce could be a schema, Dynamics as a schema, Finance as a schema. So on the publishing side, a participating system would publish through whatever its API is. Maybe it's a direct query, maybe it's a REST API or JSON or just a flat file, a delimited file perhaps, simply publishes according to its schedule, publishes its data to its schema, right? And that's it. Again, with no knowledge of whom, whatever other system might be consuming, might be subscribing, doesn't matter. On the publishing side, here's my latest data. The activity is an insert update. So new records are inserted, existing records are updated. There's no retention of prior history. It is simply a reflection of the last published set of data, right? Nice and simple and easy. Sometimes we'll see a working database. So data will be acquired into a working database and then second step into the hub, although on the publishing side, this could certainly be a direct from the acquiring interface directly into the hub. On the publishing side, it's the other side of the coin. Now here that database in the middle becomes more common and more interesting, because if we think of data being retained in its native form for exchange purposes, I might have 2 or more systems that are subscribing to the same data. Published by CRM being consumed by finance, fulfillment, and HR, just to make up 3. But they transform that data in different ways. Some of them have lookups to resolve codes, others apply some business rule to a value to get to whatever is meaningful for them. So I do have unique business rules that are very specific to the participating subscribing system. And so having a nice working data warehouse, one per participating system, which allows me to do whatever unique things I want to do, is kind of a very common technique. But if this simple model makes sense, I've now created a mechanism where data can move across systems very efficiently in a shared environment, including into my BI environment, which is simply a subscriber like any other, acquires the data of interest from multiple schemas, presumably, and then applies whatever changes, transformations it needs to make, and populates that data out through its warehouse and its mart. That warehouse, and by the way, in my consulting practice, I'm leaning away from using the word data warehouse, because data warehouse is now so laden with baggage. It's almost a dirty word. Oh, you're going to build a warehouse. We've done that before. It's enormously expensive. We had an unhappy ending, and so we don't want a warehouse. We just want marts. Very common argument. So I started to use the term persistent store, which is in part, I recognize and acknowledge, is a dodge. It's a way not to get into the warehouse argument, but it is actually more descriptive of what we're trying to accomplish here. We do still need to store data historically, persistently, so that we can build those marts. If we're going direct from source to mart, then it makes the marts more rigid. It makes them less flexible. And now when we want to change the shape of the mart or change a transformation of a business rule in the mart, it becomes much more complicated for us. If we have a persistent store in the environment, we can simply recreate the mart, because the persistent store has the data in its native form, and we can reshape, we can redesign dimensions, we can recalculate values based on the native data that we still have in hand. So it's very, very important. I'm going to talk about a data vault model here, although there are different kinds of ensemble models, data vault being the one that I prefer. But if you do a bit of research, you'll find that there are a number of ensemble flavors. One thing to keep in mind, ensemble modeling is an evolutionary concept, not a revolutionary concept. And what that means is it's still SQL Server, it's still tables and views and stored procs, it's still columns. We use all of the same techniques that we're accustomed to in traditional third normal form. It's just a different way of thinking of the way that we model data, a way that is a recognition of now several decades of data warehousing and saying, well, these are the limitations of third normal form. These are the challenges with that technique, which made sense at the time. But now we've evolved and we've recognized that change is inevitable. Our warehouse will always evolve. And How can I minimize the impact of that? How can I make that more manageable? The concept of an ensemble modeling, if we just look up the dictionary term for ensemble, an ensemble is a collection of component parts that when used together represents a whole, right? It represents a thing, right, when used together. In our case, the ensemble is made up of hubs and satellites and links, represented by, the blue and the red and the yellow diagram to the left. The concept is that a hub would represent an entity, a core business concept. So a product, an employee, a sales order, either a thing or an activity. So a sales transaction is a hub. It's a core business concept. That hub is really just an identifying component. It just has key values in it. So it identifies a customer key, for instance, in a sales transaction, a customer, a product, a date, and an employee, right? In very simple terms. That's an activity. Well, I have 4 hubs there. I have a product hub. I have my customer hub. I have the sales transaction itself, which probably has an ID of its own, right? And then I have a concept of time. I have a date or a calendar. Each of those hubs have attribution, right? The customer has a name and a type, maybe a phone number, right? There's a gender if I track such a thing. Those attribution live in one or more satellites that are related to the hubs. So I now take all my attributions and I separate them from the hub. The hub never changes, right? The hub is just the identifier of, in this case, a customer. The satellite contains attribution that may change. Maybe I change my phone number. Maybe I change my name. It's even possible I could change my gender. So that data lives in a satellite, probably more than one satellite, and there's nuance involved in that. But conceptually, there's that separation. And then the links are the way that I relate hubs together in meaningful ways. So a link in my sales transaction would link the sales transaction hub to the customer to the product, for instance. If we think of the way we manage change over time, using this ensemble concept, we're able to change the curve, change the cost, and the time it takes for us to manage change in the environment. Traditionally, in a third normal form, as my data warehouse, my persistent store becomes more mature, the cost of change, the cost of evolution skyrockets. It becomes more and more difficult to incorporate new subject areas of data, more and more difficult for me to move from the old system to the new system, right? CRM or finance or whatever that might be. I have a lot of data management, a lot of remodeling to do, a lot of ETL to rewrite, right? Very expensive, difficult to do. In the case of an ensemble model, let's say, for instance, I acquire a new company, they have a different financial system. I have my accounts hub. Now, maybe I have some new accounts, but in many cases, it's the same accounts, but the other financial system has somewhat different attribution. It has some variation in the way that it stores descriptions and names and types and that sort of thing. I can simply create a new satellite for the new system. And that allows me to not change existing ETL. Existing ETL stays in place. Existing data schema stays in place. I am now just adding new. And that greatly reduces the time to delivery for me. So far more nimble, far more accommodating of the business. Our architecture begins to look like this. It begins to look like a set of reusable components that I can mix and match according to my needs. So I can reject someone else's reality and substitute my own. I, as the business, can say, look, I have a particular way that I want to see my data in the mart. I don't care one whit about persistent storage of some of this data. Some of it I do, some of it I don't. So why should I have to wait for that data to be incorporated into the warehouse? Why can't I just go directly from the exchange directly into my marts so I can do my reporting and analysis and be on my way. So we start with this architecture where data is flowing more or less in a traditional way, although I'm incorporating late binding and I'm incorporating targeted marts in my architecture. And I'm evolving to an architecture that looks more like this, that says, well, I do have a path of data to flow where it needs to be shared across multiple systems through the exchange, where it needs to be stored persistently into my data warehouse, and then into marts for consumption. But I also have an alternative, but part of the pattern path where data can flow directly from the exchange to the mart. And I also have data that's coming through big data channels or maybe the Internet of Things, it's telephony data perhaps, that doesn't participate in the exchange because it's not being shared, but I do want to persist it. So therefore it can go directly to the warehouse as an alternative. Now I may put that data through the exchange as well, but I have an option, and that's really the point. I have options, so I want to be flexible, but I don't want to die by 1,000 exceptions. So it is important to evaluate each exception, be thoughtful, think about it and say, well, what set of components makes best sense for this solution? All right, how would we handle that integration? Let's look at our patterns and use our techniques appropriately, but create this kind of interchangeable dynamic rather than the dependency dynamic. And then last point, what about MDM? We want master data management. We have to have some sort of enterprise truth. And if we think of our MDM capability in the same way we've thought of our data integration and our persistent storage capability, we can see that there is a design for us. There is a path forward for us. Typically, we think of MDM as living primarily in our ETL stream, right? We acquire data, we do lookups to master data, we resolve those lookups, and then we pass the data along. Not exclusively, but generally speaking, that's a pretty common way for MDM to live in our environment. If we pull MDM out, maybe MDS, since we're in a Microsoft world, we pull MDS out and we think of it as a component, like we think of all of our other components. Now I can use MDM as part of my data acquisition process, where that makes sense. But I could also use MDM as an addressable component at reporting time. So in the creation of my data mart, for instance, or even on the backside of my data mart as a set of queries for reporting, I can do lookups to MDM on the fly. And so I can think of it as an independent capability to be leveraged where it's appropriate and not necessarily a dependency where all data must pass through MDM in order for it to move on to the next hurdle, which keeps me from bringing data out to ultimately my users. So if we put all of these concepts together, we think of componentizing, then the idea of data positioning comes full circle and says, look, ultimately I want to deliver data in the right place, in the right form, as the user wants it, but I still have to manage that data in some sort of a rational way. I don't want to just create a chaotic, willy-nilly sort of just push the data through quick and dirty. But if I componentize and my capabilities, but still enforce my consistencies, I can get to the architecture that's flexible, that's fast, and allows me to be successful. And with that, I think I'm handing back off to Hamish for questions.
Excellent. Thank you very much, Scott. We do have one question, and a reminder to everyone, we do have a couple of minutes, so please put your questions into the chat window. Question is, how does an application that needs several types of related data query the data exchange and get data for all these different types of data that are temporarily consistent? Maybe the price is from last week and the inventory is for this week. The total value is not necessarily the product of these numbers.
Yeah, it's a great question. So the way the exchange works, and of course there are variations depending upon the particular need, but in its simplest form, the way the exchange works is each participating system as a publisher would simply publish its most recent data. So if a subscribing system wants to acquire inventory from one system, ordering from another, and then perhaps registration information, I'm just completely making that up, from a third system, it can simply query those three schemas and acquire that data into its landing database for further processing if further processing is required. Now, what it's going to receive from those three systems is the most recently published data. So if the concept is that I want inventory from a month ago, but I want ordering from yesterday, then the ordering may come from the exchange, but I may have to go to the persistent store to get last month's data because the exchange is only going to have most current data. So in its simplest form, we always think in terms of the most current. If in fact I want to combine historical and current, then I can query from the warehouse, I can query from the exchange, and in my working database, I can manipulate according to my needs to put it all together.
Cool. Another question. Can Data Lake be your persistent data store?
Sorry, can what be?
Data Lake.
I'm not familiar with Data Lake. I apologize.
No worries.
But I will answer it this way, with apologies for not recognizing that platform or that technology. The shape of the persistent data store or the technology or the platform of the persistent data store can be anything you want it to be. Functionally, it is a place for me to store data as it changes over time. And independent of whatever technology I choose to perform that function, it's still a component in the architecture. So it can be anything I want it to be. And again, I apologize. It's probably silly that I don't recognize Data Lake, but there you have it.
Okay, cool. Please describe the roles and responsibilities, i.e. business versus IT.
Yeah, great question. Those of us in business intelligence tend to, in the ETL area, for instance, we tend to have an ops or a technical team that handles data integration for operations, but very often we'll have a business functional team, technically capable, but business centered to do the kind of BI ETL things. And then the question of who owns the warehouse often resolves down to, well, that is an operation for a technical group, but the mart might be owned by the business. And so we kind of divvy things up in that way. In this new architecture, those lines become blurred a bit. So on the business side, what I would expect to see is my business analysts, certainly, because they understand the functional needs, but also have the sufficient technical skills to be able to communicate to more technical audiences. I would have a technical team that handles the data exchange that is purely technical, although they need to work with the BAs to understand what data is of interest, but it's a purely technical role. The data warehouse, the persistent store, and the data marts, that's a data modeler role. And it's important that I do have strong data modeling skills there because no one's perfect, but the more perfect you can be in designing the correct models pays dividends, significant dividends in the future. I don't want deep technical but not data model capable people designing those stores because they'll make wrong choices because it's not their discipline. So I have functional SMEs, I have business analysts on the business side. On the technical side, I have data modelers, and I have ETL developers as the primary roles.
Awesome. Okay, thank you very much. Well, that gets us to the end of the questions. What I might do is just wait a minute or so, see if anyone has maybe that one last question, because we're sort of 5 minutes away from ending. I just want to make sure, because I have a wee bit of an accent. I said data lake before.
Oh, I'm sorry.
Can
I,
data lake be
yeah,
your persistent data store?
yeah,
Yeah,
sorry.
sorry, mate.
That's all right. I'm accused of having an accent as well, although I don't hear it. So yes, could a data lake be your persistent store? Now, that's an interesting question because we tend to think of data lakes traditionally as being unstructured, big data kinds of concepts. And therefore, they are very well suited to large unstructured data environments, but not necessarily defined data in the sense that we think of structured data, like a traditional relational store. So my inclination is to say no. I wouldn't have a data lake as my persistent store. I may have a data lake as a data store, certainly, but I think of the persistent store, the warehouse itself, as the structured representation of the data that I've identified from that lake that's of interest, and then I would track changes to that data where desired over time. So the data lake would be a source, but it wouldn't be the persistent store itself.
All good. Oh, thank you for that. I think that's a great question to end on. All righty, if we can go to the next slide, please. Awesome. Stay tuned for our next session, Big Data Analytics Reference Architectures, with Sergey Linyankin, and I apologize if I got that name wrong. I do have an accent. So thank you all very much for attending, and thank you, Scott, for a fantastic session. And yep, next slide, please.
And there you go. So thank you, everyone.